Let's put our theory into practice and solve a problem using what we know. So I'm going to create a problem and we'll see how we go with it. Okay, so let's say that two bodies are moving towards each other. We'll go A and B. Okay, so they're both moving. They both have momentum, and they're moving towards each other. So let's say A has a mass equal 10 kilogram and a velocity equal 5 meters per second. Now we'll say that the convention, that velocity is positive in the right direction. Okay, so with B, we know the mass is equal to, we'll say the mass is equal to 4 kilogram, and the velocity is 7 meters per second. Now, this will be negative with that convention when we use it in our formulas. Okay, so with the problem, we'll say that when A and B collide, it will be an elastic collision where they both travel in opposite directions. So after impact, the velocity of B changes to 10 meters a second to the right. So velocity A 1, velocity B 1, and then afterwards the velocity B will be 10 meters per second right. Okay, so we want to find the velocity of A after impact. So that is what we want to find. So let's calculate the momentum of A and B before the collision. So calculate momentum of A and so we'll say the momentum of A before collision, so in first state, is equal to mv A1. Okay, so we know the mass is 10 and the velocity is 5. So it equals 50. Now the units, the standard units for momentum, we can use sec-newtons or kilogram meters per second. However, in this case I'm going to stick with sec-newtons. Now we'll calculate the momentum of B, which is mvb1, which is 4 times negative 7. Which is negative 28 sec-newtons. Now, as this is a one-dimensional problem, we can calculate the total initial momentum, as it is a closed system, by the combination of these two. So, total momentum prior to impact is the momentum of A plus momentum of B, which is equal to 50 plus negative 28, which is equal to 22 sec-newtons. Now, due to the law of conservation of momentum, we know that the momentum of the system prior to impact is the same as the momentum of the system after impact. So what we mean by this is by conservation of momentum, the initial momentum of the system is equal to the final momentum of the system. So let's calculate what we know of the final momentum. So the momentum of A after impact is equal to mass times the velocity of A after impact. So that equals to 10v. Now, we don't know v yet, because that is what we're trying to work out, so we'll come back to that. So let's work out the velocity of B2 after impact. Now that equals mv B2 and is 4 times 10 meters a second to the right. So it's 40 sec-newtons. So we can say that the final momentum of the system is equal to the momentum of 1 plus the momentum of 2 after impact. The momentum of A plus the momentum of B after impact. And that equals 10V plus 40 sec-newtons. Now, having a look at this equation, we can equate the initial and final momentums. So we can say P1, which is 22 sec-newtons, is equal to P2, which is 10V plus 40 sec-newtons. Now, solving for V, we get negative 1.8 meters per second, and due to the negative convention, we know that A will actually be traveling to the left at 1.8 meters per second.